Welcome you all guys to Debugging Doubts.
You all guys might be observing that as the years pass, the computer size is going on reducing. But how do they achieve it? They all do it by reducing the size of the components, number of components, and one more basic thing is you all must know the basic concept of how to solve a given Boolean equation. So in today's video, let us see about the properties and in further video, we'll try to solve two problems.
Here are some basic properties. I can say that these are very much important in solving any type of Boolean equations. These are all are the basics you must remember. Let us go one by one properties. First property, identity law. What it says in OR gate, x plus 0 is x. So x is what? In this, x can be any values, but x should be a Boolean value. How it depends? Let's try to analyze here. Okay. Here, x plus 0 is equal to x. They are given. First, we'll consider x is equal to 0. Then, what will it become? 0 plus 0 is equal to 0. And this is equal to x. So, we have proved the first using 0. And second one is x is equal to 1. When x is equal to 1, 1 plus 0, right? So 1 plus 0 is 1, that is x. So both the condition you are getting the output as x. So this is proven. Likewise, you can also prove the second property too. That is x into 1 is equal to x. Next move to the second property, that is complement law. So you can prove using that same method, x plus x dash equals 1, right? And x is equal to 0, x value is 0 plus x dash is 0 bar. So 0 bar is 1 equals 1. So what is this 1? We have proved. And second condition, x is equal to 1. What will become? 1 plus 1 bar. 1 bar is 0 equals 1. So both the condition we are getting 1, which is already told. So that is complement law. Now next law is null law. Here it says x plus 1 is equal to 1 and x into 0 is equal to 0. Here what it says is anything plus 1 is 1. Anything into 0 is 0. So next is idempotent law. Here what it says is same thing with the same thing. If you do addition, you'll get the same thing. And same thing into same thing, you will get the same thing. So next is involution law. If you complement it twice for any value, you get the same thing. Like if I take 0 and if I complement it, what I will get? 1. And if I complement it, what I'll get? 0. But I initially started with 0. So same thing it is saying. So if you complement twice, it is the same thing. Next is commutative law. This of course you all must be knowing in the mathematics. Next thing is associative law and this is also same thing, right? Next thing is distributed law. Here what it says is x plus y into z is equals to first x plus y. Okay. So x plus y, then here what is the sign? Into. So you'll write into and x plus z, x plus z. This is distributed law. You feel like in mathematics there is no such rule for addition purpose. But here it is because these are Boolean values and also you have in multiplication side x into y plus z. This may have in mathematics, right? Equals, first you'll multiply x into y, then you'll take sign plus, then x into z, x into z. This is how you can show the distributed law. Next is absorption law. This is somewhat kind of important, I can say, because most of the equations you can solve directly by using this law. See, if x plus x into y. Now we shall prove using the Boolean value itself. Okay, x can be taken as common using distributed law. Then what will remain here? 1 plus, and what will remain here? Y is equal to, you can see see the null law. What it says? Anything value plus 1 is equal to 1. So I will write x and anything plus 1 is equal to 1. So inside it will be 1. And you can see the dual property identity law. What it says? X into 1 is equal to x. So is equal to x. Absorption law is proved by normal properties. X into x plus y equals x. Then how we can prove this? First, let us try to prove LHS. Okay, from LHS we'll try to prove RHS. We can use distributed property, right? First we'll do with this x into x, then use plus symbol, then x into y equals, you can see the idempotent law. What it says in the dual property, x into x is equal to x. So I will write it as x plus and x into y, x into y. Now can you see the absorption law? It says the same thing, x plus x into y is equal to x. So I will write it as x. This is the answer, right? We are producing these things. Now let's see the simplification law. This is somewhat also kind of important because most of the equations you may reach here and you may be confused that I will be not able to solve. But actually you can solve. This can be proved using truth table. So in truth table process, what you do is first you'll write x and what is the next input y. So you have only two inputs. Then do the columns and write 0, 0, all the truth table values. You will try to write x dash column because you have one x dash. So it will be negation 1, 1, 0, 0. Okay. See, 0 will become 1 and 1 will become 0. And in next column, we'll try to do x dash into y. So x dash into y, first is 0, second one is 1, then 0 into 0 is 0 and 0 into 1 is 0. Then we'll write next column is x dash into y plus x, that is the LHS side, right? This is LHS. See, for this column, you need to add x part, x column. Okay. Now we will add this. So 0 plus 0 is 0, and this is 1, this is 1, and this is 1. Now let us try to prove x plus y column. X plus y. This is RHS. Then we'll write x plus y. 0 plus 0 is 0, and this is 1, this is 1, and this is 1. So what did you observe? That is LHS is equal to RHS in truth table. This is how we have proved using truth table. Let's move to the next property that is very important, called as De Morgan's theorem. Here what it says is x plus y whole bar. If I consider, then it can be represented as, first thing you must break the null, that is x bar and y bar, and whatever, if it is addition, you need to convert into multiplication. And in the second thing, you can see the dual property, right? Second thing, if it is multiplication and whole bar, then what you can do is, first thing is break the chain, and the second thing is change the sign. So it is multiplication, here it is plus. This is how De Morgan's theorem is stated. This is very, very important and helpful in many of the cases. So thank you all for watching, and if you like my video, you can please like and subscribe it. Thank you for watching.